hope you are having a great conference. So this talk is about the JUCE API, which wraps all the Multibus APIs of the different plugins, VST, VST3, AU, AUV3, AAX, wraps them into a unified API. So this is what this talk is about. So quick show of hands. Who understands this reference? Wow, yes. I was really unsure about that. So I kept it in a secret slide with a video if people don't understand this reference, but I'm glad almost everybody does. Who uses JUCE? Yes, great. Who makes plugins with JUCE or hosts plugins? Okay. And who has looked at the Multibus API? Wow, this is going to be great. This is really good. Okay, so this is the outline of my talk, an introduction. I'm going to be talking about implementing Multibus plugins, how to host Multibus plugins, and a bit about the future of Multibus. So let's start off, what is Multibus? Here's your plugin or your audio processor. It has some audio coming in and some audio coming out, and JUCE always supported multiple channels of audio since the very first versions of JUCE. So having 6 input audio channels and 3 output audio channels, that's a no-brainer in JUCE. But there's a question about what these channels actually mean. You know, what is that second audio channel? Is that a left channel? Is that a right channel? And with Multibus, we added an interpretation layer on top of these audio channels. So this will tell you, are these 6 channels, is this maybe 6.0 surround, and the second audio channel is a center channel, or is it 5.1 surround? Or maybe it's not even just a single bus, maybe it's 2 buses, a main bus and a side chain bus. And I think it's really important to understand that Multibus is a layer on top of this audio channel layer. So Multibus just adds an interpretation to what these channels actually mean. But the audio channel buffer layer is still always there. You can always use that. So who needs Multibus? Who should be using this? Well, if your plugin has multiple audio buses, as the name implies, then you should be using Multibus. So if you have any side chains or aux channels, if you need to know which speaker is which, so you need to know, oh, is this a center speaker or is this a left surround speaker, then you need to be using Multibus. And on the contrary, if your plugin does not need any of that information, then it's just a pain using Multibus. You don't need to. And in particularly multi-mono plugins, so plugins that treat every channel exactly the same. I don't know, like a gain plugin or an equalizer usually treats every channel exactly the same. For those, you don't need Multibus. Some examples of Multibus plugins are plugins that have multiple buses, like vocoders or NoiseGates or drum synths. And some plugins that need the channel layout information, panners, spatializers, and then there are plugins that need both, like mixers and splitters. Usually mixers have several buses, but they also need to know, is this a stereo bus? Is this a surround 5.1 bus, so they know how to down mix the channels correctly. Okay, so let's jump straight in. How do we implement a Multibus plugin? So imagine you're a CEO of this great company called Backwards Technologies. And Backwards Technologies likes to do things a bit different, right? So we all know the NoiseGate, the humble NoiseGate. But Backwards Technologies has the inverse NoiseGate, okay? It's the best plugin in the world. So I'll give you some examples, yeah? So this is without a NoiseGate.
The birch canoe slid on the smooth planks. Glue the sheet to the dark blue background.
So I don't know, that didn't really load correctly. Maybe my internet is not so good, but...
The birch canoe slid on the smooth planks. Glue the sheet to the dark blue background.
So that's without the inverse NoiseGate. This is with the inverse NoiseGate. Everything important is missing. Super, super great. Oops, stop. Okay. So this is kind of a quick layout of how this inverse NoiseGate works. You have some audio coming in. This audio is being mixed down to a mono channel. A little low-pass filter is applied. And if there's anything useful, so if the signal goes above a certain threshold, so maybe someone's talking, it will just cut out the signal. And if no one's talking, there's just noise, then it will open up the gate. So super useful plugin. Now this plugin is not multibus because as you see here, there's nothing that really needs to know that the second channel is a center channel. There's not multiple buses, it's just one input, one output. So this is not a multibus plugin. But let's quickly look at the code of this inverse noise gate. We have constructor, add some parameters, the process block method. Here we first mix down all of the channels. So I'm getting the number of input channels. I just add them up and then divide them by the number of channels. I pass the result of this to the low-pass filter. And if the result of the low-pass filter is bigger than some certain threshold, so there might be something useful in that channel, I start a sample countdown for exactly 1 second. And during that 1 second, you see here that no audio will be let through. It'll just be zeros. So this is a stripped down, implementation of an audio processor you probably have all seen. I left away some of the not so important methods like get name and get parameters. This is the meat of an audio processor. Now all is good, you make a lot of money, but then one day, of course, the customers come along. I want more, it's not enough. This inverse noise gate needs to do more. And what they want is they want a sidechain, right? So they don't want to necessarily use the main audio bus as a control channel, but they want another input bus, a sidechain bus, with which they can control the gate. So obviously now this plugin is a multibus plugin, has more than one input bus. So how can we migrate our existing plugin to multibus? So this is the plugin that we just saw before, exactly the same code. And to migrate this to multibus, you just need to add a few lines. So this is the difference between both of them. It's not that much, but we'll go through it in detail. So let's look at the constructor. With the new Multibus API, with JUCE 4, we have a new constructor for the audio processor. So normally there was just the default constructor, but now we have a constructor where you can specify the input and output buses. So in this case, we're adding 2 input buses and 1 output bus. And the input buses have the name main and sidechain, and the output bus has the name main. We're also specifying the default layout of those buses. And I'd really, really like to stress that this is the default layout. There's much confusion on the forum. I just read this morning somebody saying, hey, I set my default layout to 5.1, but when I load it in Cubase, it comes up as stereo. And that's because they're inserting their plugin on a stereo track. This is just the default layout. In fact, Cubase and Logic hardly ever respect the default layout. This is just telling the host, hey, this is maybe a good set you want to use, but the host can change that. The host can request any layout it wants. But we'll talk a bit more about that later. So please don't confuse this default layout with the only layout that your plugin can have. This is just the default, just an indication of what might be a useful layout for your plugin. The really important thing here is the number of buses you're adding and the names. Now let's look at the process block method. So this is the inverse noise gate, and before we were using this buffer parameter, and now we have these 2 new methods called getBusBuffer. So instead of using this buffer here, we just get the audio buffers for the audio buses. So we get the audio buffer for the input, for the main input bus, and we get an audio buffer for the sidechain bus. So we now use the sidechain input. So we just replace the buffer which was here before, we replace with the sidechain input buffer, and we mix down the audio samples contained in that buffer. And similarly, before we also just had buffer here, but here we want to control the main input-output, so we replace this buffer here with main input-output, which is now the audio buffer for the main buses. So that's it. We just migrated a plugin to Multibus. It's not hard. There's usually just a change in the constructor and then changing which buffers you are using. Let's look at a different example, a slightly more complex example. Again, backwards technologies has a great new idea. They think there's just too much surround in this world. So they invented the MonoIser. It just makes anything mono. So let's do a quick demo of what the MonoIser does. So here we have a surround track. Here we have the MonoIser. So I'm just going to disable it for a moment. So as you can see here, this is a nice surround signal. But I mean, who wants surround? So I'm going to enable the MonoIser, and all the channels are now mono, but I can like listen to only the right one, maybe only the right surround. Oh no, I want to listen to only the left surround. So I can drag around this ball to listen to different channels in my surround signal, right? Because I mean, mono is the best anyway. So that's the MonoIser. If you look at the graph here, it's basically takes any surround, it kind of mixes it down that surround channel depending on the XY position of that dot, and then it duplicates the channels because maybe you're loading the MonoIser on a surround channel and then you're just duplicating the outputs so that all the outputs are the same. So obviously this plugin is a multibus plugin because it needs the channel layout information. It needs to know that, I don't know, the third audio buffer here is the right channel. So let's look at the constructor of the MonoIser. Again, we're not using the default constructor because it's a multibus plugin. We're using this bus properties constructor, and we're adding a main input and a main output, and we're specifying some default layout that the host may use or may not use. We don't know. It's just an indication of the canonical layout that your plugin may have. Then in the process block method, we do the same thing again. We get the buffers, the audio buffers for a particular bus. So here we get the audio buffer for the input bus and the audio buffer for the output bus. And then we get the channel layout of the input bus. So this true says, I want the input bus and I want the first bus on the input side. And I'm going to get the channel layout of that bus. And whoa, what do we have here? Audio channel set. It's a new JUCE class alert right there. So what is this class? So this is, audio channel set is basically just an array of speaker enums. So in JUCE 4, we've introduced speaker enums, which are like left, right, surround right, LFE. And an audio channel set is just a set of those speakers. So for example, stereo is just left, right. Surround 5.1 is left, center, right, surround, right, etc. But this audio channel set class has many, many useful methods. I'm only going to go into a few of them. There's, I think, about 20 methods you can use. The most important one is size and get type of channel. Size returns the number of speakers in the list, and get type of channel gets the particular speaker in that list. So you can iterate through all the speakers on your audio bus. You can get a string description. You can ask the plugin, hey, I want a layout with 5 channels. Like what audio channel set do you support? You can get the name of the individual speakers, and then you can also get the index inside the buffer of a particular speaker. So you say, hey, I have this audio sample buffer, it has 8 channels, but now I want the center speaker. Which index is that? And it will say, oh, it's index number 4. But this is probably the one that you're going to use the most often, is to iterate through the speakers. So let's go back to the code. So we're getting our audio channel set. We just call this set of the input. And then we use this method I just introduced. Set.size is the number of speakers in this set. And right after I say, hey, what, the 0th speaker in my set, what is that? And then I simply have this big switch statement of all the speakers that my plugin knows about, and set some location in space of where that speaker might be located. And then I do a few crazy calculations of distance and which amplitude that speaker may have. By the way, all this code is code to be able to fit on a slide. This is not how you would write this, right? This is just an example of how you use multibus. So this is part 1 of the processor. Here's part 2 of the processor. We now have the amplitudes for every channel. we now have to process all of the audio, so we iterate through all of the samples. Here we quickly check every channel, every input channel. Is this input channel an LFE channel? So we, again, get the type of the channel, of the input, and if this is an LFE channel, well, if it's not an LFE channel, we just multiply the amplitude that we just calculated, and if it is an LFE channel, we pass it through a low-pass filter. Because, yeah, the LFE channel is a bit special. It's the low-frequency emitter, typically a subwoofer. And then we just copy it to the output. So that's the MonoIser. Now, something that I briefly mentioned is that the host can request any number of channels and any number of layouts. So this default layout that we give in the constructor is just an indication of how, your canonical layout. So, but the host can say, hey, I want surround 5.1 or I want stereo. But not all layouts will make sense for your plugin. So if we look at this inverse noise gate again, it just makes sense that the input and the output bus have exactly the same channel layout, right? And this is more restrictive than the number of channels, right? You really want, let's say, 5.1 to be on the input and the output, which 5.1 has 6 channels, but 6.0 also has 6 channels. But you really want that the input and the output bus have exactly the same layout. And right now, the way I programmed this inverse noise gate, if I would bring it up in Logic, it would show me these configurations. It would say, hey, mono to stereo or mono to 5.1, which doesn't really make sense for this inverse noise gate because it's just an on-off switch. You're just passing through the audio or not passing it through. A bit more complex is for the MonoIser. Now, not all speaker positions may have been implemented by the developer, and this may seem a bit constructed at first. Well, then why don't you just implement the position of speaker, I don't know, right surround? But imagine, future surround layouts may come about, maybe ambisonic, whatever, maybe the under your chair speaker layout will happen in 10 years, and your plugin won't support that. So I've now constructed the plugin in a way that it doesn't know about the left side channels, right? Left side and right side channels. It just does an assertion. But, well, there's no way really to restrict that. Currently, if I open it up in Logic, I see mono to 6.1, which has left side and right side speakers, and then I would just get hit an assertion or even worse, a crash. Because when I implemented this plugin, I didn't know that there is such a thing as a left side speaker and a right side speaker. So the old pre-JUCE 4-way to restrict layouts was this plugin channels configurations field in the producer. And this was just a list of numbers. So this list here would say, my plugin supports anything with 1 input, 1 output, or it supports 2 inputs and 2 outputs, or it supports 3 inputs and 3 outputs, et cetera, et cetera. But this is really not a useful way to specify this. First of all, it's no easy way to extend this to multiple buses. And then it's only a restriction based on the number of channels. In this example that I just gave of 5.1 surround and hexagonal and 6.0 surround, they're all different layouts, but they all have the same number of channels. So what if I just want to allow hexagonal? There would be no way to specify this in the old version of JUCE. Often restrictions are more complex. Maybe I want to only allow channels that don't have an LFE channel. There would be no way to write this. And I think the most important reason why we want to deprecate this is this will apply to the main audio processor of your project. So currently it's not really clear in the producer which audio processor is being restricted by this field. And it happens to be the main audio processor of your plugin that you're creating, but you might, your audio processor might be a whole graph of other audio processors. How do I restrict the layouts of the sub-audio processors? There's no way to do that in JUCE currently. And many of the other fields, this applies to many of the other fields as well. That's why we slowly want to get rid of those fields. So, yeah, the short answer is try not to use this if you don't have to. So new way to restrict layouts is a new callback called is buses layout supported? And you return false if your plugin does not support that layout. So for the inverse noise gate, it's really simple. You just check, does the main input channel set equal the main output channel set? If it is, we support it. If it isn't, we don't. And we don't even care about the sidechain bus, because the sidechain bus, we're just mixing it down to mono anyway. We don't care what kind of layout that has. So it doesn't even appear here. And if you implement this, these two layouts will just disappear, and logic will correctly only show mono. For the MonoIser, it's a bit more complex. Here, as a developer, I've kind of implemented an array of all the speakers I support, all the speakers I know the positions of, and then I iterate through the speakers, and if I find a speaker that I don't support, so that's not in this list, I return false. And if I know about all the speakers, then I return true. So by doing this, logic will not show the 6.1 surround format anymore, the format I don't support, and I have no more assertions or crashes. Okay, so any questions so far? Because I'll otherwise move on to hosting. Yep.
Do you support like bigger loudspeaker setup like 22.2, or is it restricted to surround?
The question was, do we support much bigger layouts like 22.2? No, we don't. I think the biggest we support is octagonal and 7.1 in the surround world. But we can add that, definitely. I mean, we only support octagonal and 7.1 because we basically took a common denominator of what the plugins support. So VST3 supports, I think the latest version supports something new, but when we wrote this, the highest it could support was octagonal surround. AAX only supports 7.1, that's the largest it supports. Audio units also only 7.1 surround is sort of the largest set. So we took, we looked at this is a wrapper for the existing APIs of plugins. And the existing APIs of plugins, when we wrote this, didn't support anything more than 8 channels.
Yeah, you spoke before about not using the old method anymore, and the safe way is just leaving it empty, right?
Yes, exactly. So the question was that field in the Pro Juicer, we shouldn't be using it anymore. I mean, you can use it. We've tested it, so you can definitely use it. It's just, I think, like if you are going to be composing your audio plugin with more audio processors, like using the audio graph internally, then it becomes very confusing what that field actually means. And that's why we suggest not to use it. And then you just leave the field empty. Okay, now let's move on about like how do we host multibus plugins. And we're going to do an extensive demo at the end because there's really not much code about hosting the plugins. So here I have code, this would be pre-JUCE 4 of how you would host a plugin. Here I'm hosting a VST3 plugin. I just create a plugin instance of some path to a plugin. I call set play config details with the number of inputs and output channels, the sample rate I want, the buffer size I want. I call prepare to play. And then I call process block a few times. I know this is a bit contrived example. This is maybe some offline processor. And then at the end, I release the resources. Now with JUCE, before JUCE 4, before Multibus, the 6 and the 6 is the total number of input and output channels. And this would work, but even before Multibus, this would work with Multibus plugins. It's just that those numbers are interpreted as the absolute total number of input channels. So if you count, if you sum up all the channels of all the input buses and sum up all the channels of all the output buses, that's what those numbers meant. So that's where the limitations are. You can only set the total number of channels. There's no way to say, hey, I want stereo on bus 1 and I want quadraphonic on bus 2. There's no layout information, it's just numbers. And maybe the worst of all, there was no way for set play config details to fail. So there was no way in the old API to see if this was actually supported. So with Multibus, we just add these 2 lines. So everything stays the same, but now we have a new method called set channel layout of bus. And the first argument here is is it the input side or the output side, so true or false. And then here we have the bus index, and then what channel set we want. So let me just turn off here my mobile phone because that's somehow making noises. Okay, so here we create this audio channel set, this class that we discussed earlier, and we create a channel set which contains a speaker layout of 5.1. And then we just say, hey, I want to set the input, the channel layout of the input bus to 5.1 and the channel layout of the output bus to 5.1. And there's one issue with this is that it's kind of repetitive because when you set this, the plugin already knows the total number of channels because it already has a default layout, so it already knows the total number of channels. And now you're setting the channel layout of individual buses. The audio processor can always work out the total number of channels. So you can now call this set play config details without the first two arguments. We had to rename the method for backwards compatibility issues, so it's now called set rate and buffer size details, but you can get rid of those two first arguments because it's implied when you change the layouts. And another big feature that came into Multibus hosting is that you can interrogate Multibus plugins. So let's say Backwards Technologies got a bit more modest, and now they just want to write a little console application which interrogates your plugin. It just spits out as much information it can about your plugin. So pre-JUCE 4.3, there was really not much you could interrogate. In fact, you could only get the default input channels and the default output channels. But again, this is the default. Like, the plugin could support anything else. But there was no way in JUCE where you could say, hey, do you support this layout? Or what is the maximum number of channels you support if you were hosting a plugin? So this thing would just output, default number of ins 1 and default number of outs 2. With Multibus API, there's a new method called getBusCount, which gives you the number of buses here true on the input side, and if it's false on the output side, and then you can call getBus, which, hey, it returns another new class, the audio processor bus class. So there's a second new JUCE class we have, which is the audio processor bus class. And it says, again, this has, I think, 30 new methods. It's a big class with lots and lots of useful methods. I'm only going to go through some of them. Get name, obviously. What is the name of this bus? What is the default layout of this bus? And then, is this layout supported? Probably the most useful method, right? Is like, hey, does the sidechain bus support 5.1 surround? You can also say, hey, I don't really care about the exact layout, just give me a layout with 5 channels. And you can also get the maximum number of supported channels. And then this last method is a bit complex, but it's also very, very useful. If you're setting the channel layouts of buses individually, what can happen is, imagine the inverse NoiseGate again. If you set the layout on the input side of the bus to, let's say, 5.1, then the output will also change to 5.1. So you sometimes just want to know if I would hypothetically change the layout of this bus to 5.1, what will happen to the whole layout of my plugin? Because you don't know how, otherwise you wouldn't know how your layout would respond to a certain layout change. Because it could be very, very complex. You could have you could have a splitter where there's a single input bus and many output buses, and if you change the layout of the input bus, all the layouts of the output buses change to that layout. So that would be a huge change. And this function lets you query that without actually changing the layout of the bus. So let's go back to the code. We iterate through the buses, and then we just use some of these methods I just introduced. We get the bus name, we get the default layout. Again, you could do a lot more here. And this particular program would output something like this, right? It would say the first input bus is main, the default layout is stereo, etc. But I think this is best showed in a demo. We have recently So when we added this multibus stuff, we added all of this stuff to the JUCE demo host. And now let me just change the audio settings. We're on HDMI, so we don't want all of those. So let me just load a plugin, for example, the audio file player from Apple. And I don't know, some music. And well, you all know how this works, right? So I can connect the audio file player to the output and play some audio. But there's something new let me disconnect this for a moment, disconnect all pins. Let me load another file, a surround file, 5.1. So there's a new function that we've added to the host. If you right-click on one of these nodes, there's now Configure Audio I/O. And this brings up a new window where you see the buses, their names. If you click on it, Apple didn't name this bus, they just have an empty string here, and you can set the layout of that bus. And this queries the plugin, like which layouts do you support, and it does that all behind the scenes, and you can look at this code, right? This is all open source. So I'm going to load this to be 5.1 surround. So if I go over here, I can see which channel this is. I can see down here, where my mouse is, I can see, this is the center channel, this is the left surround channel. So let me just, hook up the center channel and the left surround to the audio output. And if we listen
Front
to it,
center.
there we go.
Left surround.
So that particular file just, it goes through every channel, and we only hear the center and the left surround. But really, the power of all of these Apple audio units comes in that you can combine them in really useful ways. And one of the best plugins that Apple provides is this multi-channel mixer. So let me load this. Here you can see that this Apple plugin has multiple input buses. They all have different colors. And again, I'm going to go to the Configure Audio I/O, and here I can see all the different buses. Has 8 input buses and 1 output bus, and we're going to now remove some buses. So this is also what Multibus supports. You can remove buses and add buses for plugins that support it, and the Apple plugins support this. So I'm going to be removing all of these buses here. I'm going to say, hey, I want the input side to be 5.1 and the output to be stereo. I can connect this. And bring up the interface. By default, the gain values are down in this Apple plugin, so I have to and nothing happens. Hey, that's great. Okay, sorry, I don't know what this is, but that's very odd. Let's see if they're... Just see if this is still working. Or if maybe the audio...
Front left.
Yeah, that's not working. That's strange. Enable... Okay, I don't know. Let me just get the example. Okay. Sorry, I just tried this before for the demo. I don't know why this is not working. There's like a lot more to figure out here. Like there's an audio mixer. Look, this has 64 input channels. Again, it kind of loads up in this default layout. This is what Apple intends, and you can just remove all of these buses if you want to. This does not. This is only stereo. This only supports stereo, but you can like mix a bunch of channels together. I'm really strange that this is not working, but okay. So that's what you can now do in the plugin host. And another example of this interrogation API is that you can now very easily create wrappers between, like wrap different plugin formats. That was not really possible before because you would need to interrogate the plugin about which formats it supports and which buses it has to be able to wrap plugins to different formats. So here you can see that I'm just wrapping, I don't know, some loaded plugin. So this is just an audio processor and I just pass on all the callbacks to some underlying plugin. And here I can say, hey, this plugin should be an audio unit with the AU type AUFX. It should be the filter from Apple. And now I'll run this in Cubase. Obviously, Cubase doesn't support any audio units. And here's the Apple filter. There you go. So, I don't have time now, but I just, if I comment this out here and put this in, this would be an Apple filter with a sidechain, and that all works. Okay. So, let me quickly talk about the future of Multibus. Right now, this audio channel set class that specifies the layout of a particular bus, we want to add that to more classes. So we want to add this to the audio format reader and writer. We want to add this to the audio source so that when you're you want to know the channel layout of a particular audio device. We want to add an audio source mixer that understands layouts so that it correctly mixes down surround sound to stereo. And then this example that I wanted to show, but I don't know why it didn't work. This is what we would have ended up with, like a kind of a little complex graph where we have multiple buses involved. This is really only possible in OS X currently because of the Apple audio units, the set of useful audio processors, and we want to kind of have an equivalent thing in JUCE so that we have some useful basic audio processors to kind of build up these complex graphs. Another thing is that it's really hard as a host to call process block correctly in a real-time setting. This is hopefully correct. You need to lock a callback lock. You have to check if the plugin is suspended. You have to check if it's bypassed, and then call the correct function. So we really want an easier wrapper around calling the process block method. Okay, so I talked about that certain types of plugins require channel layout information and bus information, plugins with sidechains and aux channels. The new Multibus API can be used to host and implement these type of multibus plugins. It's quite easy to extend existing non-multibus plugins and hosts to be multibus. There's a new audio processor bus class which allows you to inspect the properties of an audio bus, and more support for this channel layout information will be added to more audio classes in JUCE. Okay, thank you. And as everybody got the reference, I'm not sure if I need to show this video, but I don't know if the internet is good enough. Okay, yeah, well.
Lilu Dallas Multipass.
Yeah.
Multipass.
Lila and Multipass. You know this is Multipass. Lilu Dallas, my wife. We're newlyweds. Just met.
Multipass.
You know how it is. Bump into each other, sparks happen. Yeah, she knows it's a Multipass. Yeah, anyway, we're in love.
Okay, thank you.